Hello, I'm Asnate, also Egle, but mainly Asnate. I will tell you about my journey with road data analysis with dashboards. I'm representing Latvian State Roads today, and little introduction. So, road maintenance as a part of road life cycle is important not only for its users' safety by keeping the road in good condition and free of hazards, but also to extend the lifespan of the road by taking timely preservation type measures, therefore reducing or postponing the need for costly road reconstructions in the future. One of the methods for road preserving is resurfacing, but in order to determine whether such a method is still possible and a road reconstruction is not yet necessary, the results of measurements that characterize the quality of the road surface are analyzed. These measurements are obtained during regular road inspections and surveys. The road and street resurfacing guidelines describe the data sets that characterize the quality of road surface and combine them into a summary matrix that makes it possible to more clearly define the boundaries of characteristic sections where different resurfacing technologies will be used. The resultant condition of a road section is determined by the data set or criterion which shows the lowest result. All of these criteria are divided into up to 6 categories from A to F, where A and dark green indicate pavements in relatively the best condition, and F and dark red indicate pavements in need of reconstruction. In order to avoid having to create such static matrices from scratch for each new project, an interactive dashboard was created for testing, which, following the same principle as the summary matrix, displays overview information through maps and charts that can be analyzed more easily, quickly, and visually better. To get to the end result, of course, each data set is prepared in spreadsheets by error catching and merge of instrument measurement output files. Also, new columns are added for better analysis in dashboards. Datasets are added to ArcGIS Pro, visualized as lines or point features according to the coordinates included in the attributes and symbolized according to the predefined criteria of payment condition assessment. Also, there are pop-up windows configured with arcade expression language to make, for example, link to Google Street View of each element's location. As several similar datasets were created, Model Builder was also used to automate the process. Next, the new layers are published to ArcGIS Online and different maps are created for specific dashboards. The analysis of the data represented in the maps has been done with both ArcGIS dashboards and ArcGIS Experience Builder. On the way to the big goal, there was also created dashboards that analyze only a specific data set. Here is an example to demonstrate how the payment surface module dashboard works. So there is an instruction manual attached, and each box has a short instruction with the necessary steps to display the information. Next, as we zoom in, the section of interest is selected on the map with the select tool. In this case, the section of the road A6 from 55.6 kilometers to 58.6 kilometers, and it is immediately apparent that once the data has been selected, a comparison of values between years as well as between lines appears on the right-hand side of the serial graphs when the years of measurement is selected. The data is also selected in the data table, and the bottom and the minimum, average, and maximum values are calculated and displayed in the panel on the left. Statistics on the number of measurements made in a given year are also included in the pie chart. It is possible to select the points of interest in data table, and they will appear on the map, in the graphs, and in all other dashboard windows. The dashboard I have just demonstrated were one of the first I created, and I tried to put as many analysis tools as possible in them, where the selections change depending on another analysis tool, which in turn change depending on the third analysis tool, and so on, resulting more confusion than comprehensively analyzed data. This led me to the conclusion that the more complex and fuller of different analysis tools a dashboard is, the more difficult it is not only to understand and use it as a user, but also for me to edit as a creator. From one crowded dashboard, I created two smaller ones, where one dashboard basically provides data downloads and other data analysis in charts. By summarizing all the pre-processed data layers and the insights gained on creating dashboards, the expected result was achieved. A compilation of datasets, for example, on data collected in 2021 on major roads. By putting pavement quality measurement data on maps and dashboards, it is allowing to identify potentially critical road sections way faster and visually easier, therefore make database decisions, see tendencies, predict payment condition, and make decisions for future management and maintenance work, and facilitate easier data exchange between the client and designer by sharing dashboards or exporting needed data. The report works by category selectors, where you select the road number and the mileage of the section of interest. The background of the chart contains colored bars that visually define the A to F value, while the curves indicate the right and left lane data. As in guidance matrix you saw before, all diagrams in the series are placed one below the other in order to place the displayed data in a similar and linear reference as possible. But in order to avoid as far as possible inconsistencies in the linear reference, in cases where one of the data sets is missing data at a given start or end, it is possible to apply a scroll bar to each chart, which will shift the kilometer value of the chart to the desired one. Each chart can be pulled up to full screen for a closer look, and of course the map have legend, layers, and all the important things. A convenient tool for analyzing data without having to build a complex tool are the guides that can be added to the background of a serial graph. The graph, in combination with the guide, allows a lot of information to be displayed, both the measurement value of each band and the estimate of that value. To give the many test products a single place to test them, instead of sending out multiple links, a common test product page has been created in Experience Builder. Here the user can find both the data analysis solutions that have been developed and the maps on which these solutions are based. All dashboards have the integrated data downloads. Each dashboard is designed with two variations, using the map to select data or selecting values in the category picker to make them easier to edit later. By using arcade expression language code, where a hyperlink is created from the coordinates of point, Google Street View is also created for each data point to allow not only a numerical and graphical, but also a visual view of the road condition and possible reasons for the data value. Also, the simplest type of dashboard is shown here, whose task is basically just to select the required data by filtering or making it on or selecting it on a map and downloading this data. And this easier type of dashboard was created in Experience Builder. So that was quick and all. Thank you.
Very impressive. Anyone has questions? On meil küsimusi?
Good.
Okay. Very good example of dashboards. Any this year, next developments for the new applications? Have you any plans regarding this?
I hope next year we will have this, all the system ready for it to integrate it in the Latvian State Roads GIS system.
Are you also moving to this digital twin and 3D? And
Maybe when I study further in university,
I saw it was a huge digital twin already. Very impressive. Thank you.
Thank you.